Alright then, this lesson is now adding color bleed and combining our SSS shader with the MIA shader. First thing I'm going to do is just take a look at our model where we left off on the last lesson. I brought it into a different environment just to see how it lights with an IBL image, and it lights okay. It doesn't look great. The subject is a little red, the skin's a little dry and flaky, but at least it's not freaking out, it's not acting strange. So straight from the studio to this outdoor IBL, at least we're on the right track. Let's do a couple things to make our shader better. So adding color bleed. Color bleed has to do with different wavelengths of light passing into the skin and traveling farther. If you start reading these papers about skin, and there's lots of them from computer graphics people, they write about this stuff all the time, and it's called wavelength dependent scattering. And basically red light goes much farther through the skin than green, and blue is the least far. So basically it's very wavelength dependent how this light travels through the screen, through the skin. So what we're going to do is modify our shader to do this type of thing. If you look at the book from NVIDIA called GPU Gems, they write about this in a really interesting way. Even though it's for real time, they give you some numbers for the red, green, and blue, and they give you a lot of information about, subsurface scattering and how the specular should look and how the reflection should look. And then, if you read the website CG Feedback, you'll see a lot of people are experimenting with this exact same model at home. So you can learn a ton from this place. And this is where I saw a guy named Tony Sculptor who made a shader network that takes red, green, and blue and gives it different scattering radius for each one. That way you can fake a color bleed using mental ray. Also, in 2013, I'm using 2012 here, they have written this feature into the new subsurface scattering. It's called Fast Skin 2. We don't have that yet, but the idea is the same, and we're just going to do a quick network and show you how to build it. So here we have where we left off last time, our normal skin. The first thing I did is put it into a different lighting environment with just one light. And the reason is I want to see this this terminator where we go from light to dark, and my lighting setup is real simple. It's just one big area light, realistic size. Remember, my head is scaled to a real size, and then I'm using an umbrella light. This is actually an HDR image, so it's 32-bit float, and it gives you good reflections. It adds a lot of final gather light, but even better, it's cool, interesting reflections. I have a lot of lights saved as HDR images. It's a useful thing. So what we're going to do is we're going to start with an MIA shader. So in the past, we were using Color Mix as our last shader. This time, it's going to be MIA. And before we were doing 5 layers of skin. This time we're just going to do 3 layers, one for red, green, and blue. So let's start. I'm going to go get some skin. 1 skin. Always it will ask us, do we want to link to the already existing light map? And you say yes. So I'm going to grab skin, skin, and skin. And for ease of use, I'm going to be naming these guys, red, green, and blue. Okay, now into the skin is going to go, we're going to multiply by some colors. So we'll need a multiply divide. So we're going to get 3 of these. And we're going to say one of these is going to be red. So we got to give this guy input RGB, so 0, 0. So that's the red one. Green is going to be 0, 1, 0. And blue is going to be 0, 0, 1. And then our face texture is going to go right in there. So we'll say other, just to make sure. Get that window over here. Oh boy. Move. Okay, there we go. And actually I'll do it this way. These guys are going to go into, we're going to use everything in the epidermal. So basically all other parts of the shader get turned to 0. Leave your overall color on, but your specular and your subsurface, everything is down to 0. So we're going to say this guy goes into subdermal. Same here. This guy goes into subdermal. We need everything turned down. I made a mistake. It should be at the top, epidermal. It doesn't really matter. We're just picking one of the slots to use. You know, we could do everything through any one of the scattering slots. And this guy, turn everything down. And you go into epidermal, diffuse down. Okay, red, green, and blue. And then we have to multiply. Input 1 is going to be our color of the map. So each one of these guys will get out color, map, and out color, map. Then these three are going to be mixed together. We've got an R, G, and a B. We're going to mix them together, so we need a mix. And that will go here. We're going to mix three things now. We'll probably add a fourth one for backscatter. So we will say color 0, color 1, color 2. We were putting together three things. We're going to add, and add. Then these guys are going to go into an MIB, or MIA, I'm sorry. The reason we like MIA is because it has true reflection. It uses the BRDF, the bidirectional reflection distribution function. And it's just the scientific, it's the real world way of doing reflections. And when we see specular, that doesn't really exist. It's really a reflection, and this is the better way of doing it. As well, it has ambient occlusion built in. It's just a physically based shader, and it has all the passes. So be sure you do MIA pass X. So this guy is going to go into the bottom. Near advanced, at the very bottom, we have this thing called additional color. And that's where our color is going to go. Because we're pumping in so much color, we turn the color contribution of this thing to 0, and we'll let diffuse be 0.3, because that's what it was on all these skins. These skins used to be 0.3 up here, but now we've turned the diffuse down. But that was the diffuse weight here, so we'll let this add that. We're going to put in a roughness of 0.25. Reflectivity, this will probably map real soon. Glossiness, this is another valuable thing. Glossiness is how much blur. You know, I'll do 0.8 for, or 0.1 and 8 samples for now, but we're going to increase this quite a bit. Another thing we have to do to make sure this works is we have to put our light map into the shading group of the MIA. So that means this light map that we were using on the other guy has to go all the way into the light map shader. It's the same as this guy had to do the same thing. So your shading group always has to have that. Okay, now I've got basic stuff going on. One more thing about our R, G, and B. Now these guys are added together, similar to the way epidermal, subdermal, and back were all added. We've got R, G, and B added. So we took red times the map, green times the map, and blue times the map. Another thing we got to do is make sure all of our scales are correct. In the past, we were using 400. But now, because our radiuses are going to be shrunk, let's shrink that down to 40. This is a flexible thing that will probably change. And we turn off screen composite. So this is something we got to do on all of them. 40. And same rules. The reason we turn off screen composite is because we're going to use IBLs to color or light the thing, and we're going to render in 32-bit float, so we don't care if it passes. Now our big thing is these weights and the radius. Now we have a red radius, a green radius, and a blue radius. And this one I accidentally went to the wrong place. Epidermal. You know, it doesn't matter. We could have done them all in subdermal, all in epidermal. We're just using one part of the shader. Okay, so now we've got different weights. I looked at the NVIDIA paper, this slideshow, and I got weights for R, G, and B. So now my weight for red is 2.7. Not the weight. The radius, 2.7. I'm going to make my weight as 1. Then green is going to get 0.43. Notice these are smaller numbers. And blue is going to get 0.22. 0.22. Once again, our weight goes to 1. Keep in mind, weight is just a multiplier by the whole thing. I'm just going to make them all 1, 1, and 1, so they're all equal, red, green, and blue. But now we're saying red scatters the farthest, green less, blue the least. So now we've changed how much they scatter through. And let's do a quick render, and we'll see what we get. I make sure that it's applied, and I am going to pause right here while we render. Alright, I've just unpaused it, and here's our render. It took 1:14. It's not great, but we can see it does have potential. You definitely see the color bleed. This is the old render. But obviously we got to add the bump, and we've got to adjust our numbers. So I'm going to stop this, and in our next lesson we're going to adjust the numbers to get a much better look.